In Chapter 10, Question 5, we were introduced to the concept of a reversible reaction, a reaction in which the forward reaction and the reverse reaction are happening at the same time. And we saw how a water tank in this sort of H shape can model something like that, where the water on the left is flowing to the right, but at the same time the water on the right is flowing to the left, so that overall it looks like nothing is happening. Now, in this water tank model, it's particularly useful because we can say that the left side are like the reactants in an equation, and that the right side are like the products in an equation, and the dividing line is the arrow between those two. Now, this particular question is asking about Le Chatelier's principle, and Le Chatelier's principle says that when you add a reactant, or add a product, or remove a reactant, or remove a product, any change to this equilibrium will be minimized by the equilibrium. I think the easiest way to think through this is through an example. So let's say you add reactants, you add some water to this left side. What happens? Does the water just stay there in a sort of big block and just makes a cube of water on top? No. Instead, the water moves, it mixes with the rest of the water, and ultimately it goes to the right. So in other words, if you add a reactant, the equilibrium will shift to produce more products. Okay. Let's say you open up a hole at the bottom of this container on the reactant side, so you remove the reactants. It's draining out. Now what happens? Is it only the reactant side that loses water? No. Everything loses water. The water flows to the left side as it drains. So a conceptual chemistry way you can describe that is by saying that when you remove reactants, equilibrium shifts to the left. Okay. What happens if you add products? Let's say you pour water on the right side. Does it just build up as a cube of water? No. It shifts to the left to help minimize the change. So if you add products, equilibrium shifts to the left to produce more reactants. Okay. What if you open a hole up at the bottom here and you start draining out the products? Does it just create a vacuum on the product side? No, it's tied to the reactant side. And so the water shifts to the right to replace the water that's being drained, to minimize the change. So when you remove products, equilibrium shifts to the right toward the products to produce more products. Using this sort of water tank to predict how the water or how the molecules will flow or turn into each other as you add or remove products or reactants, that's Le Chatelier's principle. And to state the principle in a short way, it says that when you change an equilibrium, the equilibrium will shift to minimize the change. Okay, let's see how that works in the context of some of these problems. So the first thing you want to do is to identify whether the molecule they're giving you is a reactant or a product. And once you do that, you'll use this water analogy to try to figure out which way the water will flow in. So first, they give us CHO2 minus. Now let's look in this whole reaction, and we see that CHO2 minus is a product. So we're dealing here with a product. And here we're adding that. So it would be as if we were pouring water to this right side. Pour water to the right side, and where does it flow? It flows to the left. And so the way you would want to phrase that is given to you in the question. The question says, predict whether each of the following changes causes the system to shift in the direction of products or reactants. And we can see here that the system is shifting in the direction of the reactants. That's where that arrow in the water is pointing. So the way you would write this is you'd say the equilibrium would shift in the direction of the reactants. Okay, let's go through that same process, that same thought process, with this second one. So the first thing we'd want to do is to figure out whether we're dealing with a reactant or a product. What they give us is HCHO2. And if we look for it in the reaction, this is a reaction, we see HCHO2 on the reactant side. So we're going to be adding reactant. It would be as if we were pouring water onto the left side, or, oops, I'm sorry. So what we're dealing with is definitely a reactant. So then we want to look at what we're doing with it, and here we're removing it. So it would be as if we opened a drain up at the bottom and the water started draining out. How would the water in the tank flow if that happened? The water would go to the left to help minimize the change. In other words, the equilibrium would shift in the direction of the reactants. So you'd say the equilibrium would shift in the direction of the reactants. All right, how about C? So the first step is to figure out whether we're dealing with a reactant or product. What they give us is H3O+. If you look in the equation for H3O+, you will see that it is a product. Okay, so we're dealing with a product. And what are we doing to it? We're removing it. So that would be like opening up a hole and draining the water out of the product side of this little water tank. What direction would the water flow in? It would flow to the right to replace the water that's being lost. And so you would say the equilibrium of the reaction, just like the water, would shift in the direction of the products to minimize the change. All right, let's try D. Now in D, they give us HCHO2. First thing we need to do is to figure out whether that is a product or a reactant. HCHO2, it's on the left side, that means that it is a reactant. So we're dealing here with a reactant. And what we're doing is adding it. So that would be like pouring water into the left side, the reactant side of this water tank. And if you do that, how would the water flow? It would flow to the right to minimize that change. So you would say the equilibrium of the reaction would mimic the equilibrium of that water there. And it would shift in the direction of the products. And you would want to state this using these sort of technical terms. So you could see in this problem how the equilibrium in a reaction where the forward reaction and the reverse reaction are tied together because they're both happening at the same time, that equilibrium will shift, it will change to produce more products or produce more reactants when you add any of these different compounds to the mixture. And it will shift in a predictable way, the way that we can predict using this little water tank analogy to help minimize the change that you're making to the system. And that principle is Le Chatelier's principle.